Hello friends, this is EGS002 SPWM driver board, and this board is very popular for making a pure sine wave inverter, and let's have a close look on it. It consists of EG8010 application specific integrated circuits for generating the SPWM signal to control 4 MOSFET connected in H bridge, and it consists of 2 MOSFET drivers for driving a complete full bridge. And here is the LM393 voltage comparator for current sensing. And on the back side of this driver board, here are some jumpers for changing the parameters of this driver board. Like in my case, jumper 5, jumper 2 and jumper 7 and jumper 8 are sorted. So sorting the jumper 5 selects the output AC frequency of 50 Hz, and sorting of jumper 2 selects the 3-second soft start mode, and jumper 7 and jumper 8 selects the dead time of 300 nanoseconds. You can change the position of the jumpers according to your requirement. And today in this video I am going to make a pure sine wave inverter using this SPWM driver board. And here is the inverter circuit that I have already created for this project. Here I am using 4 IR3205 N channel MOSFET for making a H bridge. I have connected a black and red wire to supply the 12 volt DC power to my inverter through a 12 volt lead acid battery. Here I have connected 3 screw terminals for connecting a switch for AC voltage feedback and connecting a 12 volt fan here. And here I have connected 2 spade terminals. Here is a 10 kilo ohm potentiometer, so you can set the output voltage of your inverter according to your mains supply. And here I have using a 10 kilo ohm resistor instead of using a 10 kilo ohm NTC thermistor. This is because recently I do not have a 10 kilo ohm NTC thermistor, so I am using this 10 kilo ohm resistor here. But when I will receive the 10 kilo ohm NTC thermistor, I will replace this resistor by thermistor, and this is necessary for temperature protection. Let's connect everything together. Now turn on multimeter and select 750 volt AC range, and then press the switch to turn on the inverter, and on the display of the multimeter you can watch the output voltage of my inverter, and that is 90 volt. So here is the potentiometer that is used to adjust the output voltage. I want to keep the output voltage of my inverter to 220 volt. So take a screwdriver with flat tip and rotate the knob of this potentiometer and see the effect on the multimeter screen. Rotate the potentiometer knob in clockwise direction and the voltage value slowly rise up. Now the output voltage of my inverter is 222 volt. Now let's connect a load to our inverter. Turn off the inverter before connecting the load. Now again press the turn on button. And you can see the output voltage of my inverter is 222 volt, and the bulb is glowing very well. Now I am going to connect this 100 watt 220 volt light bulb. Now press the turn on button again, and you can watch on the screen of the digital multimeter that output voltage is now 193 volt, not 220 volt. The reason behind it that my battery is not fully charged, so the output voltage drop to this value. So friends, I have shared all the information about my project in the video description, like schematic and the necessary hardware to make this project. So thanks for watching.